It's a pain. I'm sorry. Okay. So your linkless animation is not due until Thursday because you had 2 assignments this week and they're both pretty substantial. I know they are. This is a hard week for us because we're looking at these really complex topics. So for the animation, we're going to do a little bit of that together so that I can give you kind of the graphical side of it. So I'll give you the part to build the display, and then you can add the stuff to control it and make it happen. We'll do a little bit of review. Thursday, we have our Unit 3 exam. Let's take a look at that. Now, the hard questions on the Unit 3 exam are going to be the big O things, like what big O is this instance? What big O is this instance? So have some cahoots set up with some of those questions that come directly from the question bank, the most boring cahoots ever, because they come directly from the Java question bank. But we'll look at those and I'll have them set up where you can do them online. So if you prefer those over the practice exams, you can use cahoots instead and have a little bit of a challenge with others. The hands-on, let's take a look at it before we go off. This one is going to be very similar to the one you did last week where you were comparing the execution times for the prime number calculations. Only for this one, you're going to be doing the different sorts. So you should be able to copy the sort algorithm directly from Ravel for all of them except the radix sort because you're doing that one. So you should have a radix sort too to add for that column. Now, the big thing on this one, remember, if yours comes out saying that, depending on the order you have them in, that no matter what, the second sort type you call is like always more efficient, remember you need to clone that array. Make sure that every sort is running off the exact same data. So the exact same array. You can't generate a new one with new random numbers because that would be different. It must be generate an array with random numbers, clone that exact array for each of these sorts because we want the same exact numbers in the same exact order for each of our sorts so that we're really comparing apples to apples. So any sort of difference, we wouldn't have the same exact data, so we wouldn't have a valid comparison. So your output is going to be that table comparison. So hopefully you can reuse a lot of that code from that last assignment. Yes, sir?
So we can reuse our radix sort?
Yes. And so if you look at this one, you can even use the internet. So finding these sorts and getting all these sort algorithms down, it's open for you guys to use your code, the code from Ravel, so that you can get all those different sort algorithms in there. So you don't have to develop them all.
Should that be one program with the same? Can we make that one program called 2, 4, 6 sorts?
Yeah.
Yes.
So it should be one program. And if you think about those classes that we did last time, that would be the easiest because you could just have a class that had your selection sort in it that you can call because you want to make sure you're using the exact same array.
Or use functions.
Right, either way.
Function.
Either way is fine. Yes, sir?
Can we use nanoseconds instead of milliseconds?
Sure. That's fine. Just so you get a good comparison. Whatever works for you. So this one should come out pretty interesting as long as you're using good data. Now, if you run into problems with some of the sorts in the past, we've run into some of, I can't talk today or any day, we've run into some problems where some of the sort algorithms in the book maybe don't work with such large size arrays. So see what you run into. So this one will be due, let's make sure we like this date. Right now it's the 16th, which is next Tuesday. So we have the animation thing due Thursday and your hands-on due next Tuesday. After this, we really will settle down, I promise. We just have kind of this area where we have a little bit of hecticness because of all this advanced stuff that we're looking at. Our next few chapters, we're going to be getting into the really high level stuff, like using the network, doing some multi-processing, looking at databases. A lot of that stuff we'll do a little bit of sampling, and you won't have a huge number of assignments to do for it, because one thing you'll be working on is this awesome group project. Let's take a look at it. Notice it's due in week 14. That's why it says week 14 here in week 12. So this one, last week, some people were talking about, working on programs that were real similar in different classes. This one got me last year. I hope I can keep from doing the same thing this year. I had an ordering system going on in C# and in Java too, and then I couldn't keep track of which one was which. So you're going to create a system to order at Subway. So you want to ask them what kind of sandwich, obviously, type of bread, type of meat, type of cheese. Give them up to 3 veggies, what type of sauce they want, and whether they want salt and pepper. This needs to be a GUI project so that it's nice and easy to use and pretty to look at. Your groups are going to be the same as they were for the last project. So you guys have gotten used to working with each other. Now, the required documentation that you're going to turn in is a real high-level project log. This is going to be your narrative that talks about how things progress. So it's not going to be any specific format or anything like that, just kind of general notes. On this day, we were able to meet in class. We talked about these 3 things. Then you might have something else on this day. We got together via Zoom and we hashed out this problem. Just some sort of major log so that you can look at it. This kind of stuff is documentation like a project log. I'm going to tell you guys, I am really bad at this kind of stuff. This is a real failure for me on my part. It's hard for me to remember to do things like that every day, to go in, or even every week or every meeting. But I've worked with people who were experts at it. And I've worked with people who had no problem logging everything that happened every single day. And those people are ones that were always able to explain what kind of issues had occurred in the project development. If there were questions about what kind of contribution different team members had made, they were always able to say, well, if I look at my document, I see that they did this, they did this. And they're always really straightforward. Jay, do you have anything to add? Jay's worked for the government where they have the most strict documentation requirements.
It's ridiculous.
I wouldn't be able to do it. But people keeping track of things, I've seen people get promotions and stuff because they were so good at keeping track of a project log. The bosses just felt like this was obviously a person that was competent, that they could depend on to manage others and to have more responsibility because they were able to keep track of all of these details.
But they couldn't code for crap.
Right, that's also a good thing. So maybe that's why they're so good at documentation, I don't know. But try to keep some sort of log. That's my hint to say, I'm not going to be grading it harshly. Yes, sir?
I know I just started using this, but I would be using Design to keep track of their, like, our group projects. And there's this website called Trello.
Yeah.
And it lets you make, like, project boards. So you can assign tasks and it keeps track of how long.
That's a really great thing to do. Now, you guys know, too, you can do the same things in GitHub if you like. But project management, most of the sites like that are trying to give you some sort of capability. The good thing about using Trello is that Dr. Ford likes to use it in the capstone class. So if you've got some experience with it already, that's going to help you. And it's super easy to use. I'll go ahead and log in.
You got another?
You don't have to. Yeah, there's like billions of them. Let's see, what do you think I made that one? Not that one. Ah, got it. So Trello is really, really easy to look at. You basically create these boards, and then within the board, you put in different, like, they call it channels or lanes. let's look at, how about, I want to show you my household one, because to me it kind of makes more sense. Now, when I set it up, I was kidding with my husband because we bought this new house, and I was like, we have all these things to do. I'm going to set it up on Trello, and I'm going to share it with you, and then you can update when you got something done, because he has to do all the work, right? So it was like, I'll keep track of what we need to do, and you can tell me when it got done. So the lanes that I made might not be the best lanes, but they're good. So I did, it's kind of good practice to always start with a Trello card that's your start here. So my start here, if you looked inside of that, says a little bit about this Trello board keeps track of the house. This is kind of an overview of what this board does. And then each of my lanes are things that we haven't started, things that we need to research, things that are waiting for supplies, things that are ready and just waiting for my husband to get to them, and then the things that are all done so that we can feel like we made some progress, right? Because it's important to have things in your done category, because then you feel like you actually accomplished something. Now, when you add tasks to these lanes, then you can put whatever tasks you like. So let's see, where's one of this? All of these have a lot of steps. So our downstairs bathroom is a mess. So I've added this checklist of things that we're gonna do. You know, you can tell this is gonna happen right away. But I can add in checklist items very easily. I could add comments. And Trello is going to keep track of activity for us on this thing, whatever happens. So now, not only could I add comments, my husband could add comments, anybody else that this was shared with could. They could add attachments. We could have all sorts of things going on here. So a couple years ago, I had a Skills USA team that went to nationals for the game design, and they were really good with Trello. So we just set up everything on Trello, and then I was able to attach the Skills USA documents to their Trello board so that they could find things easily. You know, instead of, you know how sometimes we're just off looking for things, you guys especially. You know it's in Canvas somewhere, searching. And so Trello kind of gives you another place to search, but it also gives you some better organization as to where you can keep things. So Jimmy, you're in the capstone. Anything else? Is that
pretty much covers
what kind of lanes do you guys have set up for yours?
We use this for our internal resources, our external resources, stuff that's done, various documentations, stuff to do.
And so what kind of channels did you set up as you went across?
Pretty much just those. Exactly.
Just those.
Yeah.
And so, you know, how you're going to
Different
set them up is
phase
going to
one,
depend
phase
on your
three.
project. Yeah, what do you have to do? Because if we always did to do, you know, that would be everything. So we can categorize things that are on different levels. Maybe things that are waiting for an outside person versus things that are waiting for inside approval. So you can try Trello. Now, if your team wants to use it, that's great. But again, that's a little bit more overhead again, something that somebody has to set up.
That wouldn't be bad for assigning different people different tasks.
It works great for that because you can put in, you can split things up exactly how you want. So it works really, really well. Plus it kind of keeps you organized because you have a list of your tasks now. And so even if we keep a list of tasks someplace else, it's nice to see them in this mode where you know exactly who's responsible for what.
Can you print the stuff from Trello to make a report?
I think so. I think I closed it. Let me get back in there. I don't see anything. Do you guys see anything? Where you can print. Do what?
You can always try Control P.
Well, that would print.
That was something messy. Yeah, I don't think you're going to get a good print that way.
That's one of the things I find that a lot of software leaves out.
Right.
How to get it to a printed page.
Now this one, the individual card, Control P is not too bad. It's going to print that individual card. Pretty good. It's got the logo, the description, the attachments, all of that kind of stuff. So you could try printing it. But yeah, Jay, you're going to lose so much capability because now all your links are dead and you can't get to anything else. So I think that's why a lot of times they just leave that print function out, because they're like, our app needs you to be online or you won't be productive. But yep, they do. You could do that snipping tool and just snip and capture some stuff.
Management doesn't want to have to log on.
Right, exactly. You don't want any hard copy. Okay, so that's your group project in a nutshell. It's going to be your subway ordering system. Notice that you don't really have to worry about money, payments, change, things like that. This is more of a nice graphical user interface system for them to create what they want to order. So it's not a full ordering system because we're not charging them or anything like that. Because I just want you to focus on the graphical aspects here. And I'd like to see some really pretty pictures, you know, of some great food that I can't eat when you're all done. So this one will be due in week 14. Your project log is just going to be kind of overview of your project. You should have included a user's guide. And this will be just a really short document on how to use the system. It should include some images. So you might want to use the snipping tool or something like that to get some images of your system into the user's guide. And then I should be able to find it on GitHub, and I should be able to see a really good README for it for your group. Now, if we go to GitHub, I mentioned that you could use it for that Trello function. Let me show you. I'll go into this repository here. And what I can do is when I'm looking at a repository like this, I can go into the projects link. And with projects, I got Trello, right? So it's basically a copy of Trello because they're saying, oh, plan your project. Sort tasks into columns off the lanes that Trello had. And you can set up all of your to-do lists and track your progress and basically all the same stuff. One thing with GitHub that's kind of neat is you can set up triggers. Might not have time to do that with your project, but that capability exists, which is pretty neat, where when programmer A says they're done with this task, it's going to kick off a notification to programmer B that it's time for them to start on their task because they were dependent, they were waiting. So you can do a lot of that stuff with GitHub. Trello is so easy and so friendly to use, though. It's hard to imagine that you would want to use something else. Other than, like Jay said, at least now you're not having to go off to another product. You know, you can just do it in GitHub. So it works pretty nice. If we set up our project, we could create it and add some boards. I'll let you fiddle with it, but I think you'll like Trello better. So when you're deciding how to split things up for your project, this one could be difficult because it's all just one GUI. So think about how you could split things up into different classes. Like maybe you could have a cheese class where somebody develops that cheese class and has the available cheeses and makes sure that everything's valid with the cheese choices. And then that way you could split up the work of this system. If you look at this system and you see one big giant main that produces this graphical user interface, you're going to have a hard time allocating out tasks to different people. So look at this system and think, how could we do it where it's class oriented and we can give different people different tasks so that we can really split up the work effectively? Usually what I hear when I'm listening is I'll hear people say, well, I'm doing the program. So-and-so is doing this stupid documentation stuff. And the third person's finding all the pictures. That's not a good way to split it up. You're not giving all three people a chance to increase their technical skills. That's what we want here. So we don't want that third person to go off and find pictures, because they really need to be working on this from a programming standpoint also, so that they're increasing their skills. Now, if you have that person that's like, I don't care, I don't want to, I just want to find pictures, then you're like, okay, fine. So you can do that. But remember, we want everybody to have a chance. So stretch them, challenge them. Let's look at that 24.7. I'm going to open NetBeans. Last week we were working on that sort class, and I hope you guys keep that and really analyze it and really understand how things are working, because to me, it's just one of the best examples we can make. I'm going to bring and take a look at it if NetBeans ever lets me. Because our sort maintenance class, where we created our print and our creating the random array, all those great things are really, really useful. One thing that I wanted to talk about, though, to ask everybody's opinion. At the end of class last time, everybody kind of all together, we came upon that dawning of realization that we were looking at arrays being passed by reference, right? And if we did a sort on an array, the array was sorted, and we didn't really need to return it back to the caller, because the caller's array is already going to be sorted. So I want you to really think about, should we have these return statements, or should this be a void method, because the array that is passed in will be sorted when we're done? I can see it both ways, and I'm sure you can too. So which is the best way? The way we have it, it's obvious that the updated output is going to be returned, but it kind of makes it hidden, doesn't it, that passing by reference is happening. That's why it took us a second. David was like, I was doing that thing. But that's why it took us a second, because the way we're doing this, it's like, it's not going to be updated. We're going to have to pass this back. So my personal opinion, I would rather see void without a return, because then I know, how in the world is this array getting sorted? Oh yeah, it was passed by reference, it's going to be sorted. That's just my thinking. Other people like to see that return of that integer array, because that kind of completes the cycle. It sort of makes sense. What do you guys think?
It would make it more clear if it's void.
Is it clearer to you? It is to me, and I mean, I know it doesn't make that much of a difference, but it would to you if you were assigned this program to work on, and after 6 days of staying up late and trying to figure out what in the world it does, you finally happen upon the fact that it was passed by reference, and so that return doesn't really matter at all. So to me, that's why I don't like it, because that could be something that could cause me time trying to figure out what's going on.
And also, passing it by return, if you get confused later in the program, you can spend a lot of time wondering where that thing came from.
That's what I'm worried about, is that I would wonder where it came from.
And who's growing?
I don't know, but they should be participating in our conversation instead of screwing around like a junior high kid in my 120 class. No, that's where people should be drawing on this silly screen, is those 12-year-olds. So drawer, what's your opinion? I have that one C# class where I've had to turn off that annotation completely because they're all 12. No, you're in the morning class. It's the afternoon.
I'm in the afternoon.
Oh, you're in the afternoon class. I always keep putting you in the morning class. She's in the afternoon. All right, so that was the only thing I wanted to revisit about that one. Should we have those returns or not? It works either way. It's up to you, but it is something to consider, because you could have Somebody crying at you that they wasted a bunch of time. All right, so I want to create a new project. If you've noticed, I kind of keep all my projects for the semester here in my NetBeans, and then that way I can find the stuff that we've already worked on. If you've cleaned yours up, that's awesome. But I'm going to do File, New Project, and I'm going to make this project be exercise 24_7. Now I'm going to be looking at what they have, and for their main class, they always name it like this, exercise 24_07. And you don't have to name it that way. That's just the way that they do it. And I'm not going to give you that part anyways, but we'll leave that in there. That's fine. So for this one, we're going to need some, first of all, some global fields, some class level fields. So I'm going to go ahead and set those up so that you don't have to worry about it on your own. This assignment, as I mentioned before, I realize it's very challenging, and I just want you to get as much of it out of it as you can. Of course, it would be nice to get all the points, but remember your lowest score will be dropped out of the assignments, and maybe even some semesters I drop the 2 lowest scores because we do so many assignments. But the first import I want is the java.util.linkedList. And then we're going to have a bunch. I'll just give you this so you don't have to worry about it. Geometry.pos. Scene.scene. Oh, scene.control.button. Lowercase c. Scene.control.label. Scene.control.text field. Scene.layout.border pane. Scene.layout.hbox. My goodness. Scene.layout.pane. Scene.paint.color. Scene.shape.line. My goodness, I keep saying that, huh? Scene.shape.rectangle. Feels like with all these imports, you could have just created all these things. Then scene.text. Text. And finally, stage.stage. You can tell it's going to do a lot, huh? Okay, so here's our animation that they want us to create. In the book, they have it. Let me delete that one. They just have a visual of it for us. They do also have a lot of code, different pieces of code, but it can get kind of overwhelming trying to figure out what you need and what you don't. So let's just look at this linked list of animation and see what we're trying to create. First of all, when our linked list is empty, we have a null head reference and a null tail reference. So this is just indicating an empty list. So you'll see in our code where we're going to build that first if we don't have any nodes in our list. Now then you'll be able to enter a value, and I'm going to go ahead and click insert, and we'll see it add that to our list. I'm going to add another one. And notice how it draws these boxes and these little arrows. And that's the part that I want to help you with, because it could be really hard to get those on your own. And we'll just copy their geometry that they already have to build those. Now, if I want to get rid of something, this will be your code where I can do 11 and search. And it tells me value 11 is at index 1. That's correct. I could do 11 and delete, and it would remove it from the list. So that's what our goal is here, is to create this linked list animation. So we're going to do it by creating a separate class. So let's use our main class here, our exercise 24_07, to declare some class variables. Now, you might decide that you need different variables or you want to handle things differently. That's fine. This list is just the way they decided to do it in their implementation. So first of all, they create a linked list. It's an empty one out of integers, and its name is list. This linked list is going to be like the real list that has the information in it that we add. So if we add the number 5 to our animation, the number 5 is going to be added to this actual linked list. Now we want to create a variable then that holds the view of the linked list that we're looking at. We'll call it linked list view. Our data name for it, our instance name, will be view. We're going to say it's a new linked list. Yes, sir?
Their linked list also allows strings.
Do what?
Their linked list also allows strings. So if we already have ours set up like that.
Sure. That's great. Now, this linked list view is a class that we're going to be creating. So that's why it's in error right now. That's the part that we're going to create, that I'm going to kind of give to you, that has all that geometry in it. So don't worry about that error. We're going to get that taken care of here in just a minute. I just want to go ahead and create the rest of our class level variables. We're going to have a button. And again, this is their implementation. They name this button BT Search. And they say this is a new button that's going to say search. That would be our search button. And like Chris already has a lot of it, he might not want to use these buttons. We'll have our insert button, bless you. and then BT delete. Now, the reason these are being made class level variables is because we want to access them here in this main class, our exercise class, but we're also going to want to access some of them in our linked list view class. Text field TF number will be the text field we use to type in the number that we're looking for. And then we'll keep track of the index in another text field. Remember how that pop-up message said what the index value was of that item that was found in the list. So some of this is just clues for you to know that these are the entities that you're going to need in your start method so that you can build this animation. I'm going to put this class in the same file. Linked list view. Now this class is going to extend the pane object. So our linked list view will create a pane that can then be passed back to that main class that has all the information on it. Our linked list view, sorry, sometimes these watches are annoying. Our linked list view needs some positions. Where is our starting X position? And where is our starting Y position? How big do we want our box? We want it to be a width of 50 and a height of 20. Our arrow line length is going to be 30. And our horizontal gap will be 80. So if you wanted to change the way that picture looked, that animation, you could change these numbers a little bit. Now in this application, we're not going to really use the animation capability of Java. We're just going to redraw this picture every time somebody tries to add something to it or delete or whatever. So it's not truly an animation in the true sense of the word. But we're going to use this method, repaint. This method is marked protected. What does that mean? Only
Everyone in the thing can use it.
Yep. So we could use it in our linked list view class or our main class. So our repaint method is the one that's going to do all the work. So the first thing it's going to do is a get children clear. And then we need to add those empty list head and tail things. So if our list size is equal to 0, we'll add those. Trying to see where we're getting an error on our list.
List dot size,
Mm-hmm.
but we don't have a list in it. And so by pulling something of this class, this dot size would wrap the current off.
Yeah, that's not what I mean. I mean, why are we not? What do you think? I'm trying to figure out what they want. I think that our list variable up here
Up top, yeah.
should be public.
Oh, it's,
It's what?
no, never mind.
Or let's make it protected. Let's see if that takes care of it. It doesn't like it. It still can't see it even if it's protected.
It should just be available even if it's private, because it's all the same. Although, you made a new class.
Yeah, it's a different class.
Well, if it's a different class, don't you have to bring over, so you'd have to do class.
That's what I'm not sure what they were doing. So let's just ignore that for now, because I think they're doing something that I haven't got to yet. So we'll get to it.
Yeah, it says, when you do the alt enter,
Mm-hmm.
add import Java util collections.
Yeah.
Great listing package.
We've got all the ones they have. I didn't try and run it though. Theirs might not work. I'll give you code that doesn't work. Let's see. Okay, so I'm just going to keep going because we will figure that out as we go. Now, in our list, again, if we have an empty linked list, we want to add that head and the tail. We're just going to use anonymous text objects, and we're going to use our starting position for starting X and starting Y to know where to draw these. And these are really not drawing items, but we're drawing text. I'm going to add 15 to the starting Y position and then label that as tail is null. Now, on our if statement, let's add an else clause. So now we're saying it's not an empty list. We have some things in it. So the first thing that we're going to do is add a new text string that says starting, or is at starting X and starting Y. So we're going to overwrite that original one. And now it's going to just say HUD. So notice, since we're using that same starting X and starting Y position of our previous one, it'll overwrite that initial entry. Uh-huh. We could do that. No, let's just go ahead and do it, because looking at the solution, that might be what I'm missing. So delete the closing curly brace that ends your main menu class and move it down to the end. And then we should be able to make that list private again.
Yeah, fix the issue with lists.
Mm-hmm.
Still got the other one with the
Yeah. Go ahead, just fix it a little bit. I think that's probably how they have it, because I hadn't counted curly braces. Looks much better. Let's do that. Thank you. We just moved the closing curly brace from the first class to the very end instead of being in the middle. It got you all messed
I
up.
still don't like the
Yeah, that one doesn't go away.
That one's okay.
What is wrong? Oh, that's what's wrong.
He's good. I can see it. Okay, so we're adding in our head message that's going to overwrite that original one. Now we're going to update or create a new X variable. And it'll be at that starting X position plus 30. And then we'll do the same thing with our starting Y position. This is going to allow us to keep those start positions, but yet move across the screen as we build new things by incrementing those positions. Now let's draw our arrow line. We'll have to create this method, draw arrow line. And it's going to require some parameters. So we're going to say we want to draw the arrow at our starting X position plus 5. And then we want to also pass in our starting Y position and our X and our Y variables. Let's create that method. I'm going to label the end of this repaint method so I don't get lost with my closing curly braces, and then put the new draw arrow method, draw arrow line right under that. Now our draw arrow line, like we saw, requires the starting X position, the starting Y position, and then we're giving it those basically ending positions that we had added to our starting positions to create. So to draw our arrow line, we're going to add a new line. Yes, close paren and then opening curly brace. Sorry. So I want to add a new line, and the line is going to be based on the parameters of X1 and Y1 is the starting position, X2, X2 and Y2 as the lengths. Now here's the part that I wanted to give you. We're going to find the slope of the line. We're going to create a variable named slope, and we're going to do this calculation. And then we're going to look at it and see if it really needs to be this ugly. So we're going to start with 4 parentheses.
Sounds about right.
Doesn't it? And we're going to put the word double inside those 4 parentheses. And then we're going to leave 1 to end our double and specify our Y1 variable. Our Y1 variable is going to have Y2 subtracted from it.
You added another parameter.
I did. So there's a few we have to keep adding.
Is there a reason to cast double when the art is
That's what I'm wondering. So let's get this, let me show you what they have, and then you guys can dissect it, because I think there might be some issues with it. So we're saying Y1 minus Y2 divided by, again, we're casting X1 as a double. It's already a double. So I'm not sure why they want to do all this casting. Okay, so that ends up being exactly what they have.
What is that?
All right, I've either got too many or not enough.
So I'm thinking we should just be able to say slope equals y1, well, we'd have to have parentheses, y1 minus y2 divided by x1 minus x2. That's, I don't know why. So if you, when you're testing, see, because I don't think, all I can think is that in different versions of the book, maybe they were passing integers or something where they had to do this casting. But the way it is right now, we're getting doubles in. We don't need that. Yes, sir, did you figure it out?
Well, in the beginning of our class, so starting variable brought in. So shouldn't our method header actually be accepting ints, not doubles? That's probably why they're casting.
Do you think that's what it is?
You may have a every time, that doesn't make much sense.
As of right now, we can't even draw a line because it's going to tell us that line 59.
Yeah, you're right. That the ints are bad.
That's a lot of parentheses.
I know.
I've got a parenthesis out of space someplace.
So we have some questions about this. Will those integers be automatically converted to doubles for these parameters? We've not seen a lot of automatic conversion of data types in Java, have we? Or do we need all this casting or not? So I'm going to leave that comment under there to remind you that as you're testing, you need to really focus on this area. But now you have at least the calculation that you don't have to go out and reinvent the wheel on. Now, once we've got our slope, we're going to calculate our tangent. Using that slope number. So we have a tangent function that we can use in the Java math library. Next, we're going to flip the arrow 45 off of a perpendicular line at point x2. They're going to create a double variable to do this called set45. And we have this literal value 1.57 divided by 2. So that would be better to be declared up at the top as a final variable. So that's where we're going to be wanting that thing to point. Now, they have another comment here. Arrows should always point towards I, not I plus 1. So if x1 is less than x2, we're going to add 90 degrees. So our set 45 then will be negative 1.57 times 1.5. Now, after we've set that arrow up, we're going to set up a variable to hold the length of the arrow ARRLEN, and we want it to be 15. And then finally, we're going to draw the arrows on the line. We're going to add our new line. Its starting location is going to be X2, Y2. Then its length is going to be X2 plus I'm not even going to say it. Yeah, there you go. Okay, ARLEN, 1, 2 parentheses, comma. Okay, so our first line is going to start at X2 and Y2, and then we're going to use all those things that we calculated to place it properly. I need to keep going now. After the array length multiplication, we're going to go to our Y2 positioning, and they actually have it within a whole bunch of parentheses because it's a parameter, and I don't know why they have it in a bunch of parentheses. But we're going to add it. See if I've got parentheses right. So because we want these lines to not be straight lines, we don't want them to be straight up and down. We want them to start here and go sideways. That's why we have to calculate the tangent and the arctangent and all those other things to calculate the degree at which it's going to slant, right? So we want it to be a 90-degree slant normally. If they're saying if that doesn't come out quite right, we might have to adjust it just a little bit. That's what that adjusting is doing. So that's what all of the calculations are for the tangent and the cotangent, is to get these lines to go down. Now let's do another one. Now I'm just copying that line because that was the arrowhead on one side, right? One side of the arrowhead we just drew. Now we want to draw the other side of the arrowhead. So we're going to change things just a little bit. Let's see where. We're going to be doing an add of a new line starting at X2 and Y2 because we again want it to start at the top of our line and come down as we're drawing that arrowhead. Our calculations, whenever we're doing the X2 calculation, instead of adding our 45-degree angle or our 90-degree angle to our arctangent, we want to subtract it because, again, we want to go the other direction. And then in our calculation for that last part, again, we want to subtract.
Are we changing the multiply to a divide or
Mm-hmm. Yeah, it's the same. So just that negative angle should be enough to make it go the opposite direction from our starting point. So we should have our line and then right there at X2, Y2, where our line ended, we'll begin to draw and we'll go at that angle coming down for that length that they've specified. And then we'll start that point again, and because our angle is negative, we'll go towards the left. That's it for that method. Pretty fun one, huh? Keep that code. Keep that code because we're not really doing that much, are we? We're just drawing a line that's not a straight line. So wonderful geometry. So now that's our draw arrow line method. Should be all done. I want to go back up to our repaint method where we were working before. So right here on line 61, at least in mine, is where I have that call to draw arrow line. So that's where we veered off and created that method. So I want to continue on from that point. We're still within our else clause, and we're going to create a for loop. We're going to control our for loop with a variable named I, and we're going to run while I is less than the size of our list. Remember, our list has all of the elements in the linked list. Now, for each of those elements in our linked list, we need to draw a box on the screen to display that element in our animation or in our visual. I would call it a visual more than an animation. So we're going to start out with a rectangle. Let's draw that rectangle, and then we'll put that number in it, and then we'll draw that line that points to the next one. Now we're going to call our rectangle rectangle. And my rectangle is going to be passed the values of X and Y, and our box width and box height. So we could change those if we wanted things to look a little differently. For our rectangle, let's go ahead and set our fill, and they want it to be white. And then they want that stroke color, the outline, to be black. And then finally, we're going to add this rectangle. To our pane. Okay, so let's take a look at the animation again here.
I think something messed up with you.
Oh, did it? You want me to start it again?
Never mind.
Is it you?
I saw some flash on
I see some stuff flash every once in a while. Now let's review what our animation is going to look like. We've already got our code in here that's going to print out this head and null message if we have no values. Then if we put a value in, this is what it's going to look like. So we're going to see that line coming down and then our arrowheads. So even our line coming into that rectangle is angled a little bit. So that's what they were saying, that they had to adjust the angle on the arrowheads because that line is already angled a little bit. Let's add another one.
If you don't adjust it, you're gonna have head and tail right on top of each other.
Yeah, or your lines would be on top of each other. And then as we keep going, this is how it's supposed to look. So let me add a couple more entries in so you can see what we're adding. So right now, we're drawing the box here that's going to hold that number, right? So did we draw this box or the entire box? We'll check. After we get the box drawn, we'll have to draw our line, and then we'll call our method to do the arrowheads.
Can we check?
look at line 72.
Sure. Yes, sir.
If you put a number smaller than 5, is it 4 or 5? Depends on how you write your insert.
Yeah.
It should. Yeah, it should. It should. Let me try it. Hang on, Jay. I'll be right there. No, it didn't. I thought it did.
Because it's a linked list, it adds it to one spot every time unless you specifically say enter it in.
Okay, so they're not, oh yeah, it's actually interesting. So it's not just sorting itself on that.
No.
No, okay,
Good.
exactly, way number one.
Good.
They only kept it sorted. Maybe. Then we put that on through the, what is that answer to the problem?
Did you find it?
I've got, somewhere I'm missing, you have 2 close parents at the end of line 73. I have 1, and it's taken.
Hmm.
That's not going to change.
I can't see any that could be missing that it wouldn't get upset about.
Found it. No, I did not.
Oops.
You've got get children and new you need to put in front of new add. That's where you're on.
Oh, he's got it. Good, good, good.
Open, space between you and one. Right. And that should get you back where we're at.
Yep, I caught up since I got a problem with the last. It's straight out.
Is it? Okay, so that's our rectangle. Let's add some more. Now we're going to add a new line. And this line is going to be x plus arrow line length. So what are we drawing there? Oops, nothing, so I'm missing something. So it says we're adding our arrow line. So that's pretty straightforward. It's just a little arrow that's going to go from our box to the next box.
Where did we declare her?
Up here in our linked list view.
I misspelled it. That's all.
I got it.
Obviously misspelled it. What did I do wrong?
Okay, so after this box height, we're ready to add an if statement. If I is less than our list dot size, -1, we're going to call our draw arrow line, and then we're going to pass it in some unbelievable parameters. X plus 40, Y plus box height divided by 2, X plus our horizontal gap, Y plus our box height divided by 2, that should be it. So remember, our draw arrow line method expects these parameters, the x1 and y1 value, and the x2 and y2 values. So that's what we're passing it based on the current location in our build. Now remember, we're only drawing that if our list has another entry, right? Because if our I is not less than our list size minus 1, we're at the last entry, and we didn't need to draw that arrow line to go on into nothing. So that's why we have that if statement. We'll only do it if we're not at the end. Now we're going to add a new text field in. Its location.
Inside the if?
Uh-huh. No, not inside the if.
Okay. Wanted to make sure.
Below the if. Thanks.
Where I'm at, I'm not
So our add here, we're going to be adding a new text field. We're going to use our X and Y values to set its starting location, but we want it to be a little bit, you know, away from those other things that we already have displayed. Now, what are we going to display in that? Well, we're going to display the number that's in our list at this position of I. Plus nothing. You think that's what it's doing?
It's concatenating that way, it's casting it up.
Ah,
And that is what's getting mad because text cannot have a string value of a number if that number is not casted.
so I guess that's an interesting way to do it.
It's concatenating it so that it outputs a string.
We're going to update our X value because we are ready now to run our for loop again to output our next box to hold our next item. Now, after the for loop, we should have all of our boxes written out with the lines connecting them to the next box, with the value within the box. So the only thing we need to add then is the tail. And then we're going to do our final draw arrow line. Starting at position X, using our starting Y variable, and X minus our horizontal gap and our Y variable is how it's going to draw that arrow line. Let's take a look at that one. It looks kind of unusual. So there's why when we do that last call to our draw arrow line, we have some unusual parameters because we're kind of backing up a little bit and making it come out of that last box. And of course, you wouldn't have to do it this way. If you want to create your own animation or graphics for this, you certainly could. This is just their way of doing it. And I just didn't want you to have to spend a bunch of time doing all the geometric calculations to figure out how to paint this. So you are good to go. I'm going to show you now. You can't run this, right? Because you're going to have to create all of the code in your start method to actually utilize this linked list view. But you have most of it. You have the majority of everything. Yes, sir?
Do we have to do this whole arrow method?
No. You do however you want to.
So we could have essentially a horizontal.
Yeah. So whatever you want to do. And if you want it to be some different colors and things like that so that you think it's a little bit more visually appealing, that would be fine too. If you want to just take this code and try to figure out how to get that start method to smash it in there, that's fine too. So here at the end of the semester.
Go to the integer function orient function
Which one?
at the end of reading right before.
Uh-huh. Got it? Okay, I know you want to mess with that right now. Sure. Do I?
Yeah, I'm looking at the last three close braces.
There it is.
I can't figure out where that one in the middle belongs. It should be. You see how we gotta do that? That one.
That's right. Tell you to get out of there.
Yeah. But I'm just wondering why. So shouldn't this be pushed in one? For alignment?
No.
Yeah. What's wrong with that? But I mean, I'm just kind of playing with that.
Yeah, it is weird. There might be something.
Oh, I know what's.
Yeah, that's probably mine too. It's the same way.
Okay, does everybody have it?
Now it makes sense.
Yes, sir.
Yeah. Does everybody still have that error on the linked list view? Yeah.
Yep.
Yeah. So I'm just gonna leave that with you. See what you can find. Okay.
This is just a quick Kahoots for you. You guys, this is a chapter 22 review for our exam in a Kahoots form. And I'd like for you to try it because, like I said, it is the exam, the questions from your quiz bank. They're not all in there, but a lot of them are. Kahoot.it. You're getting some people. Let's have a few more. Now, like I said, these could possibly be considered the most boring Kahoots ever. So do play them, because you'll never get a chance again for such a boring one. Or stressful. I'm not sure exactly what the right term is. Just what you wanted to hear, huh? Okay, let's see what we got. Estimating algorithm efficiency is kind of has a keyword in there, huh? Like your test will. Woohoo, great start. You see why I wanted to do this? Okay, but remember, it said estimating, so we probably want something that says to estimate in the answer. Remember to look at those keywords. Rachel just slammed you all. Okay, an input that results in the shortest execution time is called the easy one. Easy one. Woohoo! If we could just have all questions like that. She's still beating you. Which of the following complexity is O log n? Ooh, the most people. That's good. Good guessing.
I was about to say, once I finished, I was like, wait, there were multiple right answers there.
So that was pretty good. Now you'll see as we go through this, there are a lot of big O questions. On the average, a linear search searches good, because on average, we're going to run into something before we get to the end. So the whole list would be our worst case. For a sorted list of 1,024 elements, a binary search takes at most how many comparisons? 5, 12, 256, 128, 64, 32. Don't go green. Well, so I start out, it's 1024. I split it in half, that's 512. Split it in half, 256. Split it in half, 128. Split it in half, 64. Split it in half, 32. Split it in half, 16. Split it in half, an 8. Down to 4. Do I have to read all 4 of those to figure it out? Really good. You guys were thinking. Not 512. That's half of it. Not how many times we're going to search. Rachel is beating you all. What's that? O sub 1. Good job. The time complexity for the Towers of Hanoi algorithm in the text is so is it n to the power of 2, 2 to the power of n, or n to the power of 3? That was not an option. Because remember, n is your variable, right? So whenever you're looking at these questions, remember, n is the thing that varies, that changes. So the only way you're looking at that formula that we have an impact is if our n is the thing that we're taking it to the power of. Does that make sense? Down here, when we're using n as the base, it's not going to really have that much of an impact, right? When it changes. It's standing on top.
I just remember 2 towers.
2 towers. That'll work. That'll work. The time complexity for the selection sort algorithm in the text is
Oh, yeah, give us the one with the end.
I
I thought about that.
The time complexity for the insertion sort algorithm in the text is. Are you getting an idea of what questions are going to be on this test? I would just make a list of them, the ones that it's asking about. After you've made your list, look at the list and be like, why is this that? Why is this that? The time complexity for the recursive Fibonacci algorithm in the text is. Good. I'm going to let you guys study that. It's craziness, huh? Last year, a lot of the students wanted to drop this chapter from the final, but then some people had it all down and they were like, no, we won't. Time complexity for the algorithm using the dynamic programming approach is. Well, at least it wasn't 0. Good. The time complexity for the Euclid algorithm is. It was that, I think it was the, ooh, I don't either. Good guessing.
I guessed that over 3 times in a row. Let's switch.
I'm glad you stuck with it. The time complexity for the closest pair of points problem using divide and conquer is. Very good. The gift wrapping algorithm for finding a convex hull takes what time? The Graham's algorithm for finding a convex hull takes what amount of time? Good. O sub n is very good. Remember, it's going to increase at a linear rate, depending on how many items n there are. O n long is n log. You think that's a typo? Thank you. I'm pretty sure it is. when it starts getting with big O, I'm never sure, but yeah, it looks like a typo. Lastly, O n times n is very good. Rachel just slammed everybody. Good job, good job. She's been working. Now on Canvas, find it here. In the announcements, I created Kahoots challenges for those. Now we just did the one chapter, the worst chapter, chapter 22. The other chapters won't be focused on that big O stuff as much. But each of these are Kahoots that are based off those questions. So if you go to this link, it's only available for mobile devices. You'll have to download their little teeny Kahoots app, and then you can take the Kahoot wherever you are. So again, it's the same questions as in the practice test. It doesn't benefit you anymore to do the Kahoot over the practice test, but it might be a little bit more entertaining. And if you guys would kind of challenge each other, it'll keep track of how people are doing score-wise and who's doing the best and all of those kinds of things. So chapter 22 is that stuff that we were just looking at, all the big O. So remember in chapter 22, we talked about big O and efficient algorithms and all of that, and they get really down into it. Again, make a list of those algorithms that they ask for, write down which big O that is, and start trying to memorize it or make sense of it so that you could figure out what something would be big O-wise. The others, I don't want to do them because I want you guys to have a few minutes time. We don't have much time anyways. I'll just do another one. Chapter 23 is about sorting. And if I look at it, it does have a couple of efficiency questions in it, but it's more things like, suppose a list of these numbers is passed through a bubble sort. What does the list become after the first pass? Well, you know, since it's a bubble sort, that largest number should be at the highest position of the array. So it does have some questions like that. So again, you have Kahoots for these three. So use those, use the practice test. These are more focused, shorter, if you want to get through them quickly. So try to get you set up today for the things that you need. You have the majority of this program, except for the controlling part of it to build it. You've got some Kahoots to review for your unit exam. Anything else you need?
Even though my linked list view is not.
Do what?
That link list view stuff that's still on there.
Trying to construct a class that doesn't have a constructor. What's that?
No actual construction.
It should use the default no arg constructor. See ya. So I'll let you guys battle with that. We just have a few minutes.
I got a couple of questions.
Uh-huh.
So are we allowed to bring the pager notes for the exam?
Yeah, you can do that.
And I actually worked on a lot of this animation assignment, but when I enter values in, it just shows them as null. It doesn't show the actual value.
Oh, okay.
I don't know why it does that.
Did you have a separate linked list to hold those values like they do?
Maybe.
Maybe. Check that. I bet it's something small like that where you need to keep a separate one. Oh, good. Good job. Yeah. So I bet it's just that you don't have that number carried in another list where you can access it.
I'll take a look at it.
Yeah, see if that's, but good job. It's pretty complicated. Definitely is.
Yeah, for drawing it, it's really complicated.
Yeah, and it's just one where, I don't know, not effective use of you guys' time at this point.